All right. Welcome back to a very special Christmas edition of Advent of Code. I've got about half an hour, so the dog is barking. And so I thought what I might do is I might try to knock out the second half of this day 23 puzzle. So where we left off, we were trying to build a more efficient data structure for storing the items than a linked list. And I think what I was trying to do, so given some thought, what we were trying to do is like trying to oh, microphone's way up here. Here we go. What we were trying to do is probably not going to work, just because I was trying to combine everything into one data structure, which was an array or an object, and just sort of like replace everything with that. But given some helpful hints from the Toronto JS community, including David James, thank you again, David. He basically triggered something in me, which is like maybe 2 data structures is okay. And really, like, I have this constant need to find items by a value, which makes me like, I think I was onto something correctly with the first part, which was using a linked list. So I'm gonna put that. I'm just gonna put that back. I'm gonna continue to use the linked list, and then I'm just gonna add a data structure to help me find things quicker. So one of the problems is that every time we move, we are getting all these things, and then we have to find an item by its value. And what that means, effectively, the way I was doing it, is it would just start at the head and it would look through the entire list until it found a value that matched. And that's cool, except we're doing this up to 3 times per thing, and typically, hopefully, only once, but up to 3 times, and we're going to be doing it like 10 million times. So up to 30 million iterations of an entire list of 1 million objects is going to be just too much, and that's really what was slowing us down. So we can speed that up, and we can speed that up by adding a map, like just sort of like almost an identity map, because it's gonna be like a value map. So let's do that. So what does that look like? We've got a value map, and we are still splitting everything. We're still going through and making the items, and I still want to make the items, and I still want to find the next value by the next property of the item. But I'm thinking what we'll do is we'll also maintain this map where we key it by value. Everything else will pretty much stay the same, except what that means is that instead of finding this way where we cycle through the entire array, what we're really going to be doing is we're just going to be reading the value it mapped to get the item back. So that's the idea. Of course, it looks like we're also doing this thing here where we return null if the item is head. So we're sort of like going through the list and returning null if it doesn't find it. And that down here where we're finding it, we're saying, hey, until you find one. So it's looking through and expecting to not find it before it comes around because it's been removed, and then it's going to return a null, and then it's going to basically like decrement it and try again. So we're gonna have to replicate that logic here. And so what's the easiest way to do that? I guess what we could do is we could build the array of values that we don't want it to be in, and we could just check it like it would be a 3-element array. So let's do that. Let's get a slice of these values. And so really the slice is just going to be, we're going to have right 1, right 2, right 3. And that's going to give us an array of elements. We've got these cups 3. I mean, this is only going to work for 3. So you know what? Like maybe I'll just do that. I'm just going to hard code the value for now because I know that we don't need to support more cups than this. And I guess shuffle for cups move. This can just be 3, and we don't need to worry about cups anymore. Oh, and we actually don't need to even pass that into move anymore since we don't have it. Move the cups. Yeah, okay. So, okay, so this is right, 1, 2, 3. And we still got our start and our end. And then what we're gonna do is we're gonna have slice, and we're gonna, we wanna find values. So we wanna like, okay, so we're gonna, decval is this, and then we're going to, until, I guess what we're gonna do is we're gonna say, while decval is in slice.map, and we want to map it for values. So this would be an item, and we'll want to return item dot value. So while the decval is in this slice that we've got, we're going to do this. So now maxval and minval, these are also potentially expensive operations. So I think what we're going to want to do is, because right now maxval and minval, I mean they're doing a math max and a math min on a 1 million array element. So let's, I mean we can pre-calculate these. We can calculate these when we build it. So let's do that. Let's say max equals 0 and min. I guess what we can do, or we can check out the math max and math min of the values. So math dot min, or this is max, and then we could say values, and we're gonna blow that apart, and we'll do the same thing with min and math min values, and then this goes here still. Okay, and then what we can do, so this is never going to be bigger, but then we're going to need to grow the array, so we might have to actually change the max every iteration here. I guess max is going to be 1 million, and we could hard code that, and then the min will be 1, I think, but that will allow us to remove this maxval minval thing. So let's find maxval. Okay, so this is just going to be at max, and this is going to be at min. Okay, everything else, I don't know if this is still going to work. Is it broken? Unmatched outdent. Unmatched outdent. So what do we do? Slice equals, oh, you know, probably wants us to do that. No? Well, that's weird. All right, so we got move. So while destiny map is, let's say slice vals equals, and wow, okay, no, it's still not liking that. And now unmatched outdent. Did I indent something funny? It's possible. Unmatched outdent. So I've got an indenting problem where I've got something indented that needs to not be indented anymore. E next equals a slice val slice. Is it this? No, it's not that. Well, that's what we can do, is we can just start commenting out bits of code and seeing what if we comment that out? No, still not liking that. I don't have like whoops. That's super weird. Error, unmatched outdent. And that's after. No. Minus equals 1, decibel equals max if. Let's try that. No. Yeah, this all seems fine. And then insert the slice. I guess what we can do is we can take. What if we comment out move? This should give us unmatched outdent. That's super weird that there's got to be tab characters in here or something where there shouldn't be. Did my editor add a tab character? Let's take a look. I mean, I don't think so. That's just super weird. Let's take it to the CoffeeScript REPL and see if it complains, if it has a different complaint. No, unmatched outdent is still upset about that. Well, that's super weird. Let's try to just grab this portion and oops, put it in here. No, it's still angry about this. E next equals NE. And what if I do that? So now it complains about that. Unmatched outdent. Well, that's super weird. Let's just start removing things and seeing where the problem is. So it doesn't like this, doesn't like target, doesn't like find. Did I make like an equals where I should have made a, let's keep looking. To string, can get rid of that. Huh. Well, that's super weird. Doesn't like class list constructor. Oh my god, that's why. Okay, right. So let's put all that back. Constructor, gotta put my way up at the top here. All this was an argument apparently. All right, cool. So dest is not defined. We're not defining, oh right, and then dest, after all this, after we get the dest val, now we can use our new powerful find to find dest. So dest equals add find dest val. Whoops, guess I should not yell that. Dest equals find dest val. Okay, so, and this is breaking. Cannot read property next of null. So why is that? Well, see, line 61, target equals target next. Let's get rid of right. And I never liked right, because right is just, this is just head next. So let's be specific. And head, and this is going to be head next, 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 and then this is going to be I guess this is going to be E next. So then this is going to be start next. And this dot right is not a function, right. So this is going to be start, and this is going to be start dot next, and this is going to be start next. Okay, we still have cannot read property next to undefined, so that didn't help anything, but at least we got rid of right. And you know, all these versions of find can now be replaced with map dest val. And do we have any more finds? We do, and this is just map. Whoops. Map, and it's going to be the first. The element at 1 in map. Okay, still not liking that. Okay, so what do we have here? We got map b equals, so map val, and if index is values dot length. I guess what we can do here, this is kind of crazy. I don't think we even need to do this. We don't need to say, oh, are we at the last element in the array? Because what we can do is we can just wrap it around again at the end after the loop is done. Okay, cool. So still cannot read property next to undefined. Let's get rid of toString because I don't want it there. Equals after 1. Okay, so we got rid of that. Shuffle is still doing what we expected it to do. Head equals head next. So maybe what we did is we screwed this up. So e dot next. So maybe let's go with head next. Let's grab these out as soon as we can before we start modifying anything. So this is going to give us slice and slice vals. And let's find dest also before we start modifying anything. Okay, so still cannot read property next to undefined on line 85. So this is dest ends up being, yeah, so let's log dest val, and then let's log dest. Okay, and we'll see what's happening here. So here we get dest val 7 3. Oh, look at that, dest val is 0, so dest val should never be 0. And why is that? Because we set min to the min of values, and somewhere in here, so dest val equals max if dest val is less than min. So this should have, if dest val is less than min, log dest val min. Let's take a look at that. So this is not triggering slice vals. So let's log slice vals here. So slice vals is 367, and dest val is 0, and well, dest vals is in slice. Oh, you know what? It's in slice vals. Aha! So what if we're already there? We need to do this as well. Aha, okay, and that worked. So the problem was we were calculating 0, and that wasn't in the array, but also we should have wrapped already, so we'll have to wrap up here as well. Cool. And what do we need to know for this? We need to, like, it would be nice to be able to move this into its own thing. So let's find the destination. So that's going to, let's move all this into a method. Okay, cool. We can get rid of the logs, and we can actually just return this. So what do we need? We need the slice vals. So we could either pass that in, or we could make a method, because I don't think the slice vals really, so the slice and slice vals can be methods. So let's go slice. And this can be that, and then we'll return, right, and this is start, and start is just head next. So we can say whoop, like that, Okay, and then we can say slice vals, not equals, and we'll just say slice dot map, like that. Cool. And so that's that. And now for slice vals in here, you can just say slice vals. Oh, and there should be slice, call it. Cool. Now that was dest. So what we're gonna do is wherever we have dest, we can say, so find the dest, we can say dest equals dest, like that. Does that still work? It still works beautifully. Nice. And then we got start and end. So end is, okay. So we got our start, our end, and our dest. So we're defining these things up here, and then we start moving them around. So head next is eNext. eNext is null, and we could do some fancy destructuring here, because we're basically just like moving things around, moving them into a third thing, then moving them around again. So we could do some fancy CoffeeScript destructuring like this. We could say, I think they have this in JavaScript as well. So head next equals eNext. And then what's the next thing? eNext equals null. So we can avoid that for right now, because we don't need to null it out. We can just, what are we assigning? What's the actual thing that we're assigning next? So we're saying dest next equals start, and eNext equals dest next. Oops. eNext equals dest next, like that. But of course, dest next might have been overridden by that point. So I wonder if this still works. It does. Okay. And then we've got these dangling starts and ends, which are just this. So I can just say that head next, and then I don't need start anymore. Except I got end, which was start. So start was also that. Equals. Okay, and then can I kill that? Oh, no. I'm angry. There we go. So it ran out of space. So eNext. So head next equals eNext. What about this? Okay, so we can keep it in E. Next. I wonder why it was. Probably because we were head next before. Yeah, so what if we move dest to the top? Okay, so yeah, because we were doing it out of order. Cool. So we got dest equal, we reassign the heads. Reassign the head, or the nexts. Nexts, cool. Then we don't need any of this crap. Cool. So this is find the dest. Find the dest item, the destination item, and reassign the nexts. So that's our move. And now what we need to do is labels after. So this is dest, move, slice, well, slice. You can actually just, usually it's, I'm in the habit in JavaScript of defining these before, but of course, as an object method, it really doesn't matter. So shuffle uses move uses these. Find we're not using anymore. Good. This is like, this doesn't use any of that stuff, so I'm going to put it down at the bottom. And what else we have? The constructor and shuffle. Okay, so what do we have here? We got parsing this input. We're shuffling it 100 times and we're getting this out, but that's not what we want to be doing for part 2. What we want to be doing is we want to, first we want a million elements, and then second we want to find the product right of 1, or the item right of 1 and the item 2 right of 1. So 1 next and 1 next, and then we want the product of that. So it's not labels after. What is this doing? Yeah, we don't care about labels after 1 anymore. What we want is product after 1, and what we'll just say is we'll say map of 1. So we'll say item equals that. And then we'll say item dot next times item dot next dot next. Cool. So product after 1. And what are they saying it should be? It's chat. Okay, so we'll say assert is list dot product after 1. So we'll get rid of that. And but of course this is when we're shuffling a lot more. So let's just turn off this assertion right now, and let's get rid of that as well. So we need to make this bigger. So for I in, I guess let's call it V, because that's what we called it before. For value in, we currently have the highest max, and that's where we want to start. We want to start at max plus 1. Whoops. Up to and not including 1 million. Whoops. 1 million. Good. Okay. We're basically going to be doing the same thing. We're going to be creating a new item. Whoops. Create a new item, and we're going to add it to the map, and we still have our previous from that, and then head or equals item. We actually don't need to do this head or equals item. What we can just do is we can just say item next equals head, and that is equal to our map with values at 0. Map values. So whatever the first value in the value array that we had earlier was. So let's see if that blows up. It doesn't blow up, which is good, but we're not asserting anything either. And let's log let's log our max. Our max is 9. Oh, right. So what we want to do here is we want to say max plus equals, or I guess max equals V, because the V is always going to grow, and we're starting at the highest max. Okay, cool. So now we have a max 99999. So is that right? So that'll give us, no, maybe we want to include 1 million because we don't have a 0. Cool. So let's try that. Maybe this will bite us. Maybe what we want to do, and this is kind of weird that we're creating this thing. I mean, it seems to run fast enough, but what we could do is also we could say until max is 1 million. And then we could say plus val equals, or v equals plus equals 1. But you know what? I don't care about that. Let's leave it alone for right now. Okay, so we're initializing our head here, which is value, the first value in the string that we piped in. So basically it's going to be the first key that we ever assigned. And then we're going to say for the last item that we've ever added, which is this guy. It's going to be its next to be the head, which is also going to be that. Okay, so now since we've got fast lookups, and that'll allow us to find the destination faster, because dest will create the slice, find the slice files, and it will look it up once, and it's just a lookup on a map, so that's fine. And we got product after 1, so let's log product after 1 and see what we get. So it's angry. I is not defined. So line 86, I is not defined, it's saying. Map I. Oh, well, we actually just want map 1. So not a number. So interesting. Let's log item. And oh, I guess these need to be values. Okay, so it's giving us 12, which doesn't seem right to me, because it wanted a very, very large number. So let's see maybe what we're doing. Okay, so val 1, and the next is 3, and then the next is 4. So what did they say here? They said the next after 1 would be 934,001, and then 159. 3 and 4 is wrong. Oh, we're only shuffling 100 times, and we want to shuffle. Right, we actually want to see if this is going to work for 1,000,000. So let's try 10,000. Okay, 0.4 seconds. 100,000. 0.6. Looking good. 1,000,000. 0.5, and then 10 million. Okay. I definitely hit a thing where it went from 0.5. Okay, so finished in 2.5 seconds. That's pretty good. And that is, oh, that's the answer we're looking for. Holy shit. Amazing. Cool. So we can get rid of log item. And so removing cups, advance ahead. Yeah, I mean, what are we logging? I'm just logging that. That's it. Okay, cool. So we can assert that that's the product. And after it passes, so yeah, I guess what we want to do is we want to do the same thing. We want to log. So is this the same parse input? Determine the 2 cups immediately clockwise of cup 1. All right, so this is our input, and we're going to shuffle that many times, and then we're going to grab the product and see what this gives us. We can get rid of this old assertion. So this is what it gives us. It takes 5.5 seconds, but that includes this part, this assertion, which we also do a significant amount of work for. So let's see if this is the right answer. Come on, advent of code. Woo, that's the right answer. We can return to our advent calendar, and we can continue with day 24. Cool. So no longer need labels after 1. Got this item class, which I'm put up at the top, because why not? I'm going to use it here, new item. And you know what? We're already parsing the float, so we don't even need that line. I think this will still work. So values equals string, split, parse float. We got our min and our max. Prev equals null. Yeah, that looks good to me. Reassign the next. This looks a little confusing. This is basically the logic of what we want to assign. Could it be better? Yeah, maybe it could. It could be more readable. We could revert it. We could say we could make names for these. I think that would be fine. But we don't need to. I don't know. Maybe that'll be a fun stretch goal. Maybe we could do that. And then best val equals head val -1. And then we roll it over if it's less than the min. And then while we exist in our slice value. We want to decrement and then roll it over if we need to, and then we return the map. And then, okay, and then product after 1 is, I mean, we don't need to destructure this into item. We can just say map 1. Next val is next val. And then as long as that still works, and it does, I think I'm happy to commit this. We can commit this, and we can put a pin in day 23. What is going on here? All right, get X. All right, so day 23. Oh, I got Christmas people calling. So I should, what is this report? Move to trash, you don't need that. Day 23. All right, great. And that's, so, all right, gonna go do more Christmas stuff. Thanks for sticking around, everyone, and see you again, probably tomorrow for day 24, and then maybe day 25. I don't know. We'll see how fast they go.